Hi friends, good morning. Today we are going to discuss with NEET Physics 2026 paper. Right? Here I selected booklet code 11. So let us start with the question number 1 to question number 45. Right? Okay. So let us go to the first question. See, the speed of light in vacuum is taken as unity. If light takes 6 minutes 40 seconds to reach the earth from the sun, the distance between the sun and the earth in unity is, see, from the sun to reach the light to earth. This is sun, here earth, right? What is the time taken? 6 minutes 40 seconds. Now, velocity of light you take c is equal to 1. Then what is the distance? Distance is equal to, right, velocity into time only. Velocity already we taken unity. What is the time? 6 minutes. That is 6 into 60 second. That is, right, 360 second plus here 40 second, then 400 second. Right. So, sorry, this distance, so unit is meter. So 400. Right. 400 is the answer. Now let us go to the second question, that is match the list 1 and 2. Young's modulus. Young's modulus, right, first option, you know, Young's modulus is equal to FL divided by A delta L, direct formula, right. Compressibility. Compressibility is the reciprocal of bulk modulus. But what is bulk modulus? Bulk modulus is equal to minus P divided by delta V by V, right. So here bulk modulus is there. Bulk modulus is equal to minus P divided by delta V by V. Now compressibility is the reciprocal of this, then inverse of this comes this only, right. Now Poisson ratio. Poisson ratio is lateral strain divided by longitudinal strain. What is lateral strain? Lateral strain is delta d by d, decreasing diameter divided by actual diameter divided by delta L by L. Then this is the Poisson ratio. Then which is the correct option? A connected to 2 and B connected to 3 and C connected to 4 and D connected to 1. So option 4 is correct, right? Now let us go to question number 3. The current in the circuit shown below is all diodes are ideal and identical, right? So see here, here plus, here minus, here plus, here minus, right, here plus. So these two diode only forward biasing, these two diodes will work, right. So here 2 ohm resistance is there, here 4 ohm resistance is there. Then effective resistance 2 into 4 divided by 2 plus 4, that is 8 by 6, that is 4 by 3, right. Then what is the current? This current only we need. Current is equal to 10 divided by net resistance, that is 4 by 3, that is 30 by 4, that is 15 by 2, right. Then option 4 is correct, right. All right. Now question number 4. The angular speed of a flywheel is increased from 600 rpm to 1200 rpm in 10 seconds. The number of revolution completed by the flywheel during this time is, right. So to find, so it is increasing from 1 rpm to another rpm. So initially this value given is omega. So omega 1 is equal to 600. So this is rotation per minute. By dividing 60, we can make it in second, right. So this is 10, right, 10 pi rpm. Omega is equal to, that is actually 2 pi f, right. Then see, we can write this as 2 pi into 600 divided by 60. That is 60 cancel. This is 20 pi. Am I right? So omega 1. What is omega 2? That is 1200 rpm. That is 2 pi f. That is F frequency is 1200. To convert into second, we divided with 60, then here too, that this is 40 pi, right? Now, what is the average omega? Omega 1 plus omega 2 by 2, that is 25 plus 40 pi, that is 60 pi, divided by 2, that is 30 pi, right? Now, in 10 second, what is the total angle rotated? That is omega t only. That is, this is 30 pi into in 10 second. That is into 10, right? Then total theta is equal to 300 pi. Number of revolution they asking. Number is equal to total angle divided by 2 pi. For one revolution, 2 pi angle is there, right? So 300 pi divided by 2 pi, that is 150, right? Then which is the option? Option 3 is correct. Next, question number 5. For a simple pendulum having time period t, the variation of kinetic energy with the time t is represented by. See, here kinetic energy expression already we studied in class, that is half m omega square o square omega t. Here one a square also there, amplitude square. See, so kinetic energy is varying with the cos square omega t as a function of time, right? What is cos square function graph? Right, cos square function graph, see, it is if displacement you start with like this is yt graph for a simple harmonic function, right? So cos square function graph is in the positive quadrant only because of this square, right? But it has time period is just half t by 2 only, right? So it execute 2 time. Why? Because cos square omega t is equal to 1 plus cos 2 omega t divided by 2. Then 2 omega is the effective frequency, angular frequency. Then time period will be half, right? So t by 2. Then option 3 is correct, right? All right. Now, question number 6, that is a resistor connected to a battery 12 volt, internal resistance given, the current in the circuit is 0.6 ampere, the terminal voltage formula is E minus IR, right? Terminal voltage when the current pass through an external resistance, right? This is the terminal voltage across the cell, and here it is given EMF they given as 12 volt and current they given, that is 0.6 ampere, and internal resistance also given 2, that is 12 minus 1.2, that is 10.8, right? Which is the answer? Option 4 is correct, right? Next question number. So question number 7. A flask contain argon and chlorine in the ratio 2:1 by mass. The temperature of the mixture is 27 degrees Celsius. The ratio of root mean square speed of the molecules of two gases, argon, VRMS of argon divided by VRMS of chlorine. Atomic mass given, right? Both given. So what is the RMS speed we studied? Root 3RT divided by m. This is actually the molecular mass, right? So VRMS of, we need argon divided by VRMS of chlorine, that is, so root reciprocal only here mass, so we can take a mass of chlorine up and a mass of argon down, right? What is mass of chlorine given? That is 70, and what is mass of argon given? That is 40, that is root 7 by 2. Then which is the option? Option 1 is correct, right? Now let us go to question number 8. See, a ray of monochromatic light is passing through equilateral prism ABC as shown in the figure. The refracted ray QR is parallel to the base and the angle of incidence is 50 degree. The angle of deviation is, see, when the refracted ray go parallel to this base means it is the condition of angle of minimum deviation, right? At the angle of minimum deviation, delta, what we studied, 2i minus a 2 into angle of incidence given 50. This is an equilateral prism given. Then angle of prism is 60. Then 100 minus 60, that is 40. And option 3 is correct, right? Now let us go to question number 9. Here, energy given h nu, that is the, h nu is the energy of photon, right? And diffraction and interference, right? That is the wave nature of light only, right? Diffraction and Compton effect, that is particle nature, and lambda is equal to h by p, that is de Broglie wavelength only, right? Then which is the option? All these satisfying option 4 only, because A to 4, B to 3, C to 1, and D to 2, right? Then option 4 is correct, right? Now let us go to question number 10. See, in the first excited state of hydrogen atom, the energy of its electron is minus 3.4 electron volt. The radial distance of the electron from the hydrogen nucleus. See, this is the nucleus, this is the first orbit, this is the second orbit, right? Here only minus 13.6 electron volt, here minus 3.4 electron volt. Corresponding n is equal to what? Principal quantum number 2. What is the radius Rn is equal to R0 n square. This is 0.53 Armstrong into n is 2 minus 3.4, corresponding n is equal to 2. That is 2 square, that is 4. Then this is 2 point something. But Armstrong is 10 raised to minus 10. Then 2.1 into 10 raised to minus 10 meter. Option 3 is correct. Right? All right. Let us discuss question number 11. A box of mass 15 kg is kept on the floor of a stationary trolley. The coefficient of static friction between box and trolley is 0.12. Keeping the box stationary straight over the trolley, the maximum acceleration with which trolley can be moved horizontally. See, so one trolley is here and one box on the trolley, right? Now if this vehicle go with the acceleration a, so this will get an opposite acceleration a. Suppose this mass is m, what is the opposite force? Ma. Then frictional force acting just opposite to that. If these two frictional force and ma equal, then only the this box is at rest. That is the minimum condition, right? Okay, what is Fr, frictional force, is equal to mu into, this is normal reaction, mg, mu n is equal to mg, equal to ma. Then m cancel. Then mu given us 0.12 into 10, that is 1.2. Option 4 is correct, right? Now let us do question number 12. 5 capacitors of capacitance C1, C2, C3, C4, each of 10 microfarad, C5 equal to 2.5 microfarad are connected as shown along the battery of 50 volt. The equivalent capacitance and charge on each capacitor respectively are, see, this capacitance C5 they given 2.5, that is this is 2.5 microfarad. Now this 4 is in series, then effective is C by 4 only, that is 10 by 4, that also 2.5 microfarad, right? So microfarad, right? So this effective is 2.5 microfarad. Now this and this parallel, then net is 2.5 plus 2.5, effective capacitor 5 microfarad, right? After getting effective capacitance, what is the net charge? Cv. What is C? 5 microfarad effective capacitance into what is voltage? 50. Then 5 into 5, 250 microcoulomb. Now once this capacitor total charge starting is 250, then this route 125, this route 125. Why? Because here capacitance same, here capacitance same. Then each capacitor getting 125 microcoulomb and net capacitance is 5 microfarad. 5 microfarad and 125 microcoulomb. Option 2 is correct, right? Now, question number 13, the amount of work done to raise the mass m from the surface of the earth to a height equal to radius of the earth r will be. See, we already studied from the surface of earth, one mass to raise a height equal to n times radius. What is the formula we studied? You remembering? W is equal to, right, n by n plus 1 into mgr. But as per the question, we are raising to a height r only. R means n should be equal to 1. Then 1 by 1 plus 1 mgr. That is half mgr. Right? Then which is the option? Option 4 is correct, right? Now let us go to question number 14. Each side of a metallic cube of mass 5.580 kg is measured to be 9 cm. Keeping the significant figures in view, the density of the material of the cube be best expressed as x into 10 raised to 3 kilogram per meter cube, where the value of x is. See, so density, what? Density is equal to mass per volume. What is mass given? 5.580 kg divided by what is volume for a cube? A cube, that is 9 into 10 raised to minus 2 whole cube. By doing this, you get a 7.654 kg per meter. But in the expression here given, the least significant figures of the data given is 2. So we need 2 significant figures only. Suppose then this letters we need to skip. If you skip 5 means with a followed a number you have to add 1 here. Then answer is 7.7. Option 4 is correct, right? Now let us go to question number 15. The following plot shows variation of velocity v with a time t of a ball thrown vertically upward, and it is falling back also. Which of the following plot is are correct? See, one ball you throw vertically upward. What is the equation for that? U minus gt. Vertically upward, u minus d. It is coming downward, u plus gt. Right. So this is the velocity. Now how velocity varying? Y is equal to c minus gt plus u. That is y is equal to mx plus c format with the slope is minus g. That means it is a straight line, but the slope is negative. So this is the only possible graph representing this, right? So which is possible is C only, right? All right. Now let us go to question number 16. The sum of kinetic energy and potential energy of a simple pendulum of the bob is 0.02 joule. The speed of the simple pendulum bob at equilibrium position is approximately, see here total energy given, right? So when simple pendulum moving from top position to mean position, its kinetic energy at a mean position, its kinetic energy is maximum, right? So kinetic energy maximum means it is equal to total energy, right? So total energy equal to kinetic energy maximum, that is equal to they given 0.0. Mass they given, that is 20 gram, right? Then 20 into 10 raised to minus 3 into V maximum square, that is equal to 0.02. Now you can solve a V maximum, that is option 2, 1.41 meter per second, right? Now let us go to question number 17. In Young's double slit experiment, using a monochromatic light of wavelength lambda, the intensity of a light at a point on the screen where the path difference lambda is k unit. The intensity of light at a point where the path difference lambda by 3 is, how phase difference and path difference connected? 2 pi by lambda into path difference, right? Now if phase difference, first case phi 1 equal to 2 pi by lambda. That time path difference they given lambda 2 pi. Second case, what is phase difference? 2 pi by lambda into, that time phase difference is lambda by 3, then 2 pi by 3, right? Now first case intensity is k, that is I0 cos square phase angle, that is 2 pi, that is I0 only. Second case, say intensity k dash, cos square 2 pi is equal to 1, right? Cos n pi is equal to minus 1 raised to 1, then cos square 2 pi is 1 only. Now here I0 cos square 2 pi by 3, that is I0 cos 121 minus 1 by 2, its square is I0 into 1 by 4. Then k dash by k is equal to 1 by 4. Then what is k dash? K dash is equal to k by 4. Then which is the option? Option 1 is correct, right? Now let us go to question number 18. In the circuit shown below, the voltage appearing across the diode D will be of the form. See, here one diode is given. So during first half cycle, this end become positive, this end become negative, right? So this diode is not conducting. Not conducting means across this, here voltage is 0, but across the diode this voltage will appear, right? So you get a voltage drop across this. But during negative half cycle, this end become negative, this end become positive. Then the diode will conduct effectively. That means voltage drop across the diode is 0, but here there is a voltage will appear. But in question asking voltage drop across the diode, then diode in second case not there is no voltage drop. That means here no voltage drop. Then option 4 is correct, right? Now let us discuss question number 19. An AC circuit containing a resistance of 1 kilo ohm, capacitor of 0.1 microfarad, and an inductor of 1 millihenry are connected in series. The resonance frequency of the circuit approximately. What is resonance frequency? F is equal to LCR series circuit resonance frequency. It's a very simple formula. F is equal to 1 by 2 pi root L is given, that is 1 millihenry, that is 1 into 10 raised to minus 3, and C is what? That is 1.1 microfarad into 10 raised to minus 6. When you solve this, you get a 15.9 kilohertz, right? Then option 4 is correct, right? All right. Now let us go to question number 20. The interference and diffraction, the light energy is distributed. If it is reduces in one region, producing dark fringe, it increases in the another region, producing a bright fringe. See, you know, in diffraction and interference pattern, the patterns are distributed on either side of the screen, but the intensity difference doesn't mean that there is a violation of conservation of energy. That is redistribution only taking. We already discussed it in class, right? So based on that, as there is no energy loss, the phenomena consistent principle of conservation of energy. It is consistent only. The redistribution only it is happening. So A is true. Diffraction and interference are characteristics exhibited only by light wave. No, sound wave, ocean waves, these and all produce interference and diffraction. So option B is false. Then A is true, B is false. Option 3 is correct, right? Now question number 21. For a traveling harmonic wave, y of x t is equal to 2 cos 2 pi 10t minus 0.0080x plus 0.35, where x and y are in centimeter, right? The phase difference between oscillatory motion of 2 points separated by a distance 0.5 meter, right? Phase difference is equal to what? 2 pi by lambda into path difference. Path difference they given 0.5. This is 2 pi by lambda is what? That is k. What is k? Coefficient of x. That means 2 pi into 0 point. So we can write 2 pi into 0.0080 x. X is in centimeter. Then you can write 10 raised to minus 2 into 0.5, right? So this is the value given, right? So by doing this, you get this answer as 0.85, right? All right. Now let us discuss question number 22. The magnitude and direction of acceleration produced by a body of mass 5 kg when two mutually perpendicular forces 8 Newton and 6 Newton act on it, right? So see, consider a mass 5 kg given. It is acted by 8 Newton and another force say 6 Newton. What is the resultant? Square root of 8 square plus 6 square, that is 10 Newton, right? 10 Newton is the resultant force. Then what is the acceleration of the body? Total force divided by mass. Total force is 10, mass is given in the question, that is 5 kg. Then acceleration is 2 meter per second square. Now, so suppose this triangle theta and this force also 6, then what is tan theta? Tan theta is equal to 6 by 8, that is 3 by 4. Then theta is equal to tan inverse 3 by 4. Then see, the acceleration is 2 meter per second square and the angle which is resultant, that is tan inverse 3 by 4. That tan inverse 3 by 4, that is making with the 8 Newton force only, right? Then which is the option satisfying this? This only, right? All right. Now let us do question number 23. Here, consider an uncharged capacitor of equal capacitance 200 picofarad. One of them is charged by 100 volt and then disconnected. Now capacitor connected to the uncharged capacitor, right? The amount of electrostatic energy lost in this process is. So when one capacitor charged, that charged capacitor disconnecting from the battery and connected to another battery. If connecting case, what is the expression for energy loss of C1 C2 divided by C1 plus C2 into V1 minus V2 the whole square? This expression we derived in classroom, right? But here the problem is one capacitor is charged to 200 volt, other capacitor is uncharged. So C1 C2 by C1 plus C2, that is C by 2 identical capacitor, then 200 picofarad, right, into 10 raised to minus 12 divided by 2, and first capacitor charged to a voltage of 100 volt and second is uncharged. This only answer. Then C 2 cancel, then 1 by 2, that is 0.5, 0.5 into 10 raised to minus 6, right? Here 10 raised to minus 12, 10 raised to minus 4, here 100 and 10 raised to minus 6 only, right? Then option 1 is correct, right? All right. Now let us go to question number 24. See, the power of a crane which lifts the mass 1000 kg to a height 20 meter in 10 seconds is. See, when a body lift to a height, what is the energy? Power, you know, work by time. What is the work required to lift a body? That is mgh. Mgh by T. Here mass is given, that is 1000 and G 9.8 into H 20 meter divided by time, they given in 10 seconds, 0 cancel, then 19.6, right? 19.6 kilowatt. Option 3 is correct, right? All right. Now let us go to question number 25. In a vernier caliper, 20 VSD is coincide with 20 VSD is equal to 16 MSD, right? And each division of length 1 millimeter. The least count, see, then what is 1 VSD? 1 VSD is equal to 16 by 20 MSD. What is least count we studied? That is 1 MSD minus 1 VSD, right? That is 1 MSD minus, what is 1 VSD? that is 16 by 20 MSD. That is 20 minus 16, that is 4 by 20 MSD. 1 MSD value they given, 420 cancel 1 by 5. 1 MSD value that is given as 1 millimeter, right? Then 1 millimeter divided by 5, that is 0.02 centimeter, right? So you can write it here, multiply with the 2, here some 2, right? Then 2 millimeter divided by 10, that you can write as 2 millimeter, that you can write as 0.02 centimeter, right? Then option 3 is correct, right? All right. Now let us go to question number 26. When a ruler falls vertically, 5 different persons catch it with a different reaction time. Now, what is the correct order of the distance? How distance connected to time? When a body freely falling, right, that time, what is the distance? S is equal to, freely falling means starting velocity is 0, right? A body releases half gt square. Then it is related to time as proportional to time square. More time means more distance, right? So distance, how order of distance? See, which has greater time? B. Then B travel more distance. Then next is 21 E. After B, then E, right? Then here B, E. Then next one, more time is A. Then A only, next time D, then only C, right? So option 3 is correct, right? Now let us do question number 27. A uniform metallic wire having resistance 4 ohm bend to form a square, right? A resistance 2 ohm connected between the point B and D, and a battery 2 volt connected at the point A and C as shown in the figure. Between A and C, one battery also plugged. Then now the value of current. See, this metallic wire form a square like this. Total resistance 4 ohm. Then each arm resistance what? 1 ohm, right? Here 1 ohm, here 1 ohm, here 1 ohm. Now this is P by Q is equal to R by S, Wheatstone balancing condition. Then 2 ohm resistance not working, you can remove it. Then what is the effective resistance? 1 plus 1, 2. Here 1 plus 1, 2. 2, 2 parallel. Then effective resistance 1. Then what is the net current? Net voltage divided by effective resistance, that is 2 ampere. Option 1 is correct, right? Now let us go to question number 28. A room heater is rated 400 watt and 220 volt. If the supply voltage dropped to 200 volt, what will be the power consumed approximately, right? See, from the given parameter, you can find the resistance. What is resistance? Resistance is equal to V square by P, right? So from the given value, we can solve that. That is V square 220 square divided by 400. Now, if the voltage dropped to 200 volt also, resistance of the circuit not change, right? So new power they asking. Power is equal to, new voltage is 200 square, but resistance not going to change. That is 220 whole square divided by 400. This solve 331 point something you get. Okay, so approximately option 3 is correct, right? Now let us go to question number 29. A 100-turn closely wound coil, number of turns 100. Coil of radius also given. Radius, that is 5 into 10 raised to minus 2, has a magnetic field at its center, that is 3.14 into 10 raised to minus 3. The current flowing through the coil and magnetic moment asking. See, at the center of a circular coil, what is the magnetic field? V is equal to mu 0 Ni divided by 2R, right? Now I only asking, right? So here this used capital letter R, radius, right? Then I is equal to B2R divided by mu 0 N. All the values given, right? B given, R given, mu0 given, mu0 value 4 pi into 10 raised to minus 7. By substituting, you will get a 2.5 ampere, right? But two option giving 2.5 ampere, we have to calculate magnetic moment also. What is magnetic moment of a coil carrying current? NIA. That is N is 100, I is 2.5, and the area, that is pi r square. Pi into r is what? 5 into 10 raised to minus 2 the whole square. Then this you get approximately 2 ampere meter square. Okay. Then 2.5 and 2, option 4 is correct, right? All right. Now question number 30, a rectangular wire loop of side 8 centimeter and 3 centimeter with a small cut is moving out of a region of uniform magnetic field given directed normal to the plane. The EMF developed across the cut if the velocity of the loop is 2 centimeter per second in a direction normal to the shorter side of the loop. See, shorter side, what is the EMF producing? That means shorter side, they already mentioned, that is 3 centimeter, and it is a rectangular loop, right? So this is the shorter side, 3 centimeter, and a magnetic field given normal, and this is moving in a magnetic field. What is the motional EMF? E is equal to BLV. B already they given, that is 0.3, and the shorter side means 3 centimeter, that is 3 into 10 raised to minus 2, and velocity they given, that is 2 centimeter per second, right? So here 3, that is 2 centimeter per second, you can convert it into 2 meter per second, that is 2 into 10 raised to minus 2 meter per second, right? So 2 3 3 9 into 2 1 18, then 1.8 only, option 4 is correct, right? All right. Now let us go to question number 31. 4 statements are given. A is the mass number. The volume of the nucleus is proportional to A raised to 1 by 3. No, volume is equal to 4 by 3 pi r cube. So in terms of, see, r is equal to r0 A raised to 1 by 3 whole cube. Then it is proportional to A only. So this is wrong, but this is correct, right? Now the difference in mass of atom, its nucleus, and no, it is not the difference. See, mass defect is not the difference between nucleus mass and atom mass. It is the difference between total mass and total mass of the constituents. So option D is correct, option C wrong. Then B and D true, and then A and C wrong. So which is the option? Option 4 is correct, right? All right. Now question number 32. An unknown nucleus has a nuclear density 2.29 into 10 raised to 17 kilogram per meter cube and a mass of 19.926 10 raised to minus 27 kg. Its mass number A is approximately, see, density given, density is equal to mass per volume, and already we seen volume is equal to 4 by 3 pi r0 cube A. Before question also seen r is equal to r0 A raised to 1 by 3, right? Then they are asking its mass number A only, that is 3m divided by 4 pi r0 cube into rho. Now look here, this r0 value given, this 4 pi value also they given, right? This mass value that also given, r0 is there, density also given. Substituting this, you get approximately 19. Then option 1 is correct, right? All right. Now let us do question number 33. Savita, a 11th standard student, while conducting experiment to determine the effective length of a simple pendulum, note down the data. Time taken for 30 oscillation is 60 seconds. Calculate the length of the pendulum. 30 oscillation 60 second means one oscillation what 2 second. What is time period? 2 pi root L by G. One oscillation time only time period. Then 2 pi root L by G. Now square both side, that is 4 pi square into L by G. Pi square approximately equal to G, and 4 cancel, L is equal to 1. Then option 4 is correct, right? All right. Now let us do question number 34. An electric heater supplies heat to a system at a rate of 100 watt. If the system perform work at a rate of 75 joule per second, then the rate at which internal energy increases. How internal energy work and amount of heat given related from first law only, right? What is first law says? Delta Q is equal to delta U plus delta W. But everywhere they mentioned the rate. Then I am taking this, right? We want to find the internal energy rate only. Then delta U by delta T is equal to delta Q by delta T minus delta W by delta T. Quantity of heat given, right, at a rate, that only power they given 100 watt, 100. Work per time, that is 75 joules per second, that is 75. Then answer is 25. Then which is the option? 25. Option 4 is correct, right? All right. Now let us go to question number 35. A thin wire of length L and linear mass density M is bent into a circular ring with the center C as shown in the figure. Moment of inertia of the ring about the axis y dash is. See, what is the moment of inertia of a ring diametrically? Half mr square. Alright. Now, if it is about this axis means using parallel axis theorem, half mr square plus mr square. Right. Then 3 by 2 mr square. So we want to find this moment of inertia, 3 by 2 mr square. But initially they given linear charge density, linear mass density is m. That means for this linear mass density means what? Small m, that is capital M by L. Then total mass of the ring is ml. That is one thing. And the L length of a wire, they given L length of a wire that bend into a ring, then you can, that only 2 pi r. Then 2 pi r is equal to what? L. Then r is equal to what? L by 2 pi. Now you can substitute these values here because we need answer in terms of small m and L. Then 3 by 2, what is capital M? Small m, right? What is capital R? L by 2 pi. L by 2 pi the whole square. Then what? 3 by 2 m L cube divided by 4 pi square. That is 3 ml cube divided by 8 pi square. Then which is the option? Option 2 is correct, right? All right. Now let us go to question number 36. A galvanometer of resistance 100 ohm gives full scale deflection for a current 1 milliampere. It is converted into an ammeter of range 0 to 10 ampere. The shunt required is, see, the range required is 0 to 10 ampere. Then maximum main current, that should be 10 ampere. And galvanometer current they mentioned Ig is equal to 1 milliampere, right? And galvanometer resistance also mentioned, that is 100 ohm. Now what is the galvanometer to ammeter conversion? What is the formula we studied? Igg is equal to I minus Ig into S. All the values given, Ig given, G given, main current Ig, S only we need to find. By solving these, you get answer as 0.01 ohm, right? All right. Now question number 37. In a meter bridge experiment, the position of the cell E and galvanometer G are interchanged. We shall observe in the galvanometer. During the theoretical discussion we see at balancing point, you replace galvanometer with cell A, it don't affect the deflection, right? But if you other point means it may, suppose this side you interchange means it's left deflection and right deflection it will show, right? So both the right hand side and left hand side deflection, but at balance point not affected by interchanging battery and galvanometer. So option 4 is correct, right? All right. Now question number 38. The peak value of an alternating current is 5 ampere and the frequency is 60 hertz. How long will the current starting from 0 take to reach peak value? See, in AC current, what is the general expression for AC current? I0 sin omega t, right? Now, what is the time taken to reach current become peak value? Peak value is I0, and I0 is equal to I0 sin omega is 2 pi f t, right? This is cancel. When sin get 1, that is sin 90 only, 1, then 2 pi f t is equal to what? That should be equal to pi by 2. Pi cancel. Then what is frequency they given? 60 into t is equal to 1 by 2. Then t is equal to 120 into 2, that is 1 by 240. That means option 4 is correct, right? All right. All right. Now, question number 39. In figure given below, shows a long straight solid wire, circular cross section of radius A, carrying a steady current I. The current I is uniformly distributed across its cross section. The plot which correctly represents the variation of magnetic field. This derivation we done in class, right? What we studied during that derivation time, if any conductor uniformly carrying current like this, then inside a point you consider what is the magnetic field here. That magnetic field is equal to mu 0, right? Mu 0 I into R divided by 2 pi a square, where a is the radius, right? This is the inside magnetic field. Now outside what we studied, outside R is equal to A, then surface R is equal to A, then mu 0 I divided by 2 pi A. Now outside what we studied, mu 0 I divided by 2 pi R. That means this we derived, right? This is the 3 expression we studied. Inside, surface, outside, right? Now it is varying as proportional to R inside. That means a straight line, right? Now it become a constant because this is the radius of the cylinder wire. Then mu 0 I by 2 pi a, it is a constant at a is equal to R. This become a constant. Again, outside it is inversely proportional to R. That is 1 by x graph, right? Then option 1 is correct, right? All right. Let's go to question number 40. Two statements are given below. When the forward bias voltage across PN junction diode increases above a certain threshold voltage, the diode current increases significantly. That is correct only. During forward biasing, junction barrier width decrease so that current increases. We already studied it. Now next statement, this current is called reverse saturation current. No, this is not reverse saturation current, right? When it is significant increase there we studied some knee voltage concept only, right? So statement A is true, statement B is false, right? All right. Now question number 41. Which of the following statements are correct? Inside a conductor, electrostatic field is 0. That is correct only. Inside the conductor, electrostatic field is 0 only. Electric field at the surface of a charged conductor does not depends on the surface charge density. That is wrong. Why? Because electric field on the surface of a charged conductor is sigma by epsilon 0 n cap. So it is depends on surface charge density. Next, the interior of a charged conductor can have no excess charge in the static situation, right? That is correct only. Interior can have no excess charge. Why? Because conductor, charged conductor, charge is always residing on the surface only, we studied, right? So A true, C true. Next option is, at the surface of a charged conductor, electric field be normal to the surface. That also, surface of a charged conductor behave as an equipotential surface. So electric field must be normal to the surface. D also correct. The electrostatic potential is zero everywhere inside the charged conductor. That is wrong, because electric field only zero, potential is always a constant, right? So option E also. Then A, C, D only correct. Option 3 is correct, right? All right. Next, question number 42. For a metal of work function 6.6 electron volt, which of the following wavelength of incident radiation does not give rise to photoelectric effect? This is actually need not to do. Actually, it's a logical understanding, you know. See, out of that, it's a objective type question. Out of that, only one answer is correct. One answer only correct. Now, which was least energy of this maximum wavelength? That is 200 nanometer, right? 200 nanometer. So that only not produce a photoelectric effect, because that was the minimum energy, right? All right. So 3 is correct, right? All right. Now let us go to another question. Now let us do question number 43. In a concave lens, a ray of light emanating from the object parallel to the principal axis of the lens after refraction. See, after refraction of a convex lens, any ray go parallel to it. After refraction, it diverge like light. But a person looking from here, it is coming from a fixed point, that is known as principal focus. So appear to diverge from a fixed point, that is known as principal focus, right? So it is appear to diverge from the first principal focus. That is correct, right? All right. Question number 44. A submarine is designed to withstand an absolute pressure of 100 atm. How deep can it go below the water surface? See, one submarine, right? This is the water surface. This is a submarine at a depth. So here, what is the pressure? 100 atm. Corresponding height, say h, and on the surface atm pressure. And what is P? P is equal to P0 plus H rho G. Then this submarine withstand with this pressure only. That means it can go this height down only, right? So this is 100 atm. This is what? 1 atm. Okay, equal to H rho G. Now what is this depth? H is equal to, this is 99 atm divided by rho G. That is 99 into 10 raised to 5 Pascal. 1 atm is equal to 10 raised to 5 Pascal. Rho is 10 raised to G, G is 10, then 990 meter, right? So which is the option? Option 1 is correct, right? All right. Now let us go to the last question. Question number 45. Match the list 1 and list 2. List 1 and list 2. Microwaves, right? Microwaves. Microwave, we studied klystron and magnetron valve only producing microwaves, right? So option 4 is correct regarding microwave. Next, visible light. How visible light producing? See, atoms at a higher orbit jump into lower orbit, visible light are releasing. That is a possible. So this is here. Now gamma rays. Gamma rays produced by radioactivity. Radioactivity. And infrared rays. Infrared rays always produced by infrared rays vibrational spectroscopy, right? Atomic vibration, infrared rays are released. Vibrational spectroscopy. So all of this satisfying A4, B1, C2, and D3, option 3 is correct, right? All right. So this all about this discussion. Thank you.